Hi guys, I wanted to use this opportunity to sort of do some practice with you from the homework sheets. And from the video, you got an introduction into electron configuration. And so we're going to practice. We're going to determine the total number of electrons, and we're going to use the Aufbau principle. So the very last slide that was discussed in the video showed you the order in which the different orbitals filled. We're going to make a little note at the bottom of here because what will and this just will kind of help you, and you'll learn to look at the periodic table and discover this. So the 1s's will fill, then the 2s's, then the 2p's, then the 3s's and the 3p's, then the 4s's, then the 3Ds, then the 4Ps, then the 5S's, and let me see where I'm at. I'm just looking at the periodic table. Okay, then we're going to have some 4Ds, then we're going to have some 5Ps, then we're going to have some 6S's, and then when we have 6S's, we're actually going to get 4 F14s. Then we're going to get 5D10s. Oops, 5Ds. They can hold up to 10. Then we're going to get 6Ps. And I think that should help us with all of these kind of problems. So let's take a look. Sodium has 11 electrons. Okay, 11 electrons. So we're just going to follow this order. We're going to fill 1s first. That can hold 2 electrons. Then we're going to fill 2s, that can hold 2 electrons. Then we're going to fill 2p, that can hold 6 electrons. So now we have 6, 7, 8, 9, 10. We have to place one more. So we've done this, we've done this, we've done this. So now the next electron will go in a 3s. But we only have 1 electron. So even though it can hold 2 electrons, we only need 1 of them. All right, lead. Lead's going to be a lot bigger. Lead's atomic number is 82, and so we have 82 electrons. So we're going to start filling some of these guys up. So we're going to do 1s2, we're going to do 2s2, we're going to do 2p6, we're going to do 3s2, we're going to do 3p6. All right, now from there I go to 4s. I'm going to do 4s2. From there I go to 3d. You'll remember Ds can hold 10 electrons. Then I'm going to go to 4p. 4p can hold 6. All right, then I'm going to go to, I need more room for lead. I'm going to go to 5s2, and then I'm going to go to 4d, 10, and then I'm going to go to 5p6. Then I'm going to go to 6s2. Then I'm going to go to 4F14. Then I'm going to go to 5D, and then I have to see where lead is. Oh, yeah, 5D10. And then I'm going to go to 6P2. And if you add 2 and 2 and 6 and 2 and 6 and 2 and 10 and 6 and 2 and 10 and 6 and 2 and 14 and 10 and 2, you should get 82. So you shouldn't have to go any bigger than that. Okay, so that one's kind of a good one to do as an example. Next, we'll talk about this a little tomorrow, but this has write a ground state electron configuration for these ions. Remember that ions have a change in the total number of electrons. Okay? All right, so then if we look at oxygen, oxygen normally has 8 electrons, but this is a 2 minus charge, and so we're actually going to write the electron configuration for 10 electrons, and we can write that as 1s2, 2s2, 2p6, and that should be 10. So our normal oxygen atom configuration would be 1s2, 2s2, 2p4, but our ion has 2 more electrons, and so we do the electron configuration that way. You can work, you notice iron is a 2 plus, so that's going to have 2 less electrons. Boron is a 3 plus, that's going to have 3 less electrons. So work those problems as well. Now, part C is kind of interesting because a nice little trick is that we can use the periodic table to help us see what element it is. So we're going to look at the very last part. We're going to look at 4p4. We're going to go down to row 4. We're going to go over to the p block, all right? And we're going to count 4 over. 1, 2, 3, 4. You should see that that belongs to Se, which is selenium. Now this says you might get ions, and so 18 could be an ion. Let's think about that for a second. Okay, we have 4p6, okay? I'm gonna go down to 4p6, and that belongs to krypton. It could also be something that has lost or has gained 2 electrons, right? A p4 that has gained 2 electrons, or a p5 that has gained an electron. But for the purpose of this, we're just going to say, hey, which elements do these electron configurations kind of work with? So those are some example problems. I want you to try these before you come to class. We will talk about them some more. But really, the best way to deal with electron configurations is to just keep practicing them. So please reach out to me if you have questions, and I will see you tomorrow. But I think you guys can